The Typhoon, the largest Soviet nuclear submarine ever built. For 2 decades, this deadly nuclear weapon stalked the seas. But the Cold War is over, and the Typhoon is destined for demolition. It's a risky mission. They must dismantle, decontaminate, and dispose of 2 nuclear reactors filled with radioactive waste. A minor accident could be a radioactive disaster. It's the ultimate challenge, breaking down the Typhoon. Severodvinsk, Russia, a small industrial city on the shores of the White Sea. The winter temperatures are brutal and the daylight hours are short. In this frozen no man's land sits one of the largest Cold War relics in the world, a Soviet nuclear submarine, NATO codename Typhoon. The Soviets, though, call it Akula, the shark, and like its namesake, it's a deadly predator. The massive sub is over 170 meters long, stands over 4 stories high, and weighs over 23,500 tons. It's almost as large as a cruise liner. In active service, this first strike war machine carried 20 nuclear missiles and housed 150 elite Soviet submariners. But now the Typhoon is in the hands of this man. Captain Vladimir Piroshkov is a former Russian Navy officer who served on nuclear submarines for over 30 years. Now he has a new mission, a mission that once would have been unthinkable. He's in charge of taking this monster sub apart, piece by piece, until nothing is left.
This submarine was built in 1985. It has served out the entire Navy campaign. In its time, it was a war weapon. But sadly, its service days are finished.
The Typhoon was constructed to withstand a nuclear strike. Deliberately deconstructing it was never considered by its Soviet designers. It will be an epic challenge for Captain Piroshkov and his crew, most of them also retired Navy officers. They've already stripped the Typhoon of its top-secret technology and its 20 nuclear missiles. But Captain Piroshkov knows how dangerous this sub still is. It's powered by not 1, but 2 nuclear reactors. Inside those reactors sit radioactive fuel rods and liquid nuclear waste. If that radiation escapes, this Typhoon could be a mini Chernobyl, potentially killing shipyard workers and poisoning the local residents. The entire town of Severodvinsk could be contaminated for years. Captain Piroshkov's team of specially trained salvage experts will take the Typhoon apart in 4 carefully controlled stages. Stage 1, remove the highly radioactive uranium rods from the submarine's reactors. Stage 2, remove the reactor's liquid coolant, also dangerously radioactive. Stage 3, bring the sub into dry dock and cut its hull away, leaving only its radioactive reactor compartments. And finally, Stage 4, float the radioactive compartments to a nuclear waste dump on a remote island 800 kilometers away. The breakdown will take place in the once top-secret Zviadochka shipyard. This is where the Soviet Union maintained the ships and subs of its Cold War fleet. It looks like an oversized junkyard, but it's one of only 3 facilities in Russia that can safely break down a nuclear submarine. Captain Piroshkov's mission begins on a bitter cold February morning. 24 hours before stage 1 of the breakdown begins. The temperature outside is minus 15 degrees Celsius. The Typhoon is icebound. But soon it will begin its final journey. Captain Piroshkov has kept the Typhoon powered down for the last several months. Enough time for its nuclear fuel to cool down to a safer radiation level. Deep in the reactor core, the fuel rods are still radioactive, but not hot enough to risk a nuclear chain reaction when they're removed. Powered down, most of the sub is dark, like a ghost ship haunted by the loss of a bygone era. The Soviet Navy first deployed the Typhoon-class submarine during the Cold War in the 1980s. It was the largest submarine ever built. Only 6 of its kind were ever constructed. It was designed with World War III in mind. A mobile attack weapon armed with 20 intercontinental ballistic missiles, each carrying multiple nuclear warheads. From deep beneath the sea, the Typhoon could hit targets over 10,000 kilometers away. A single one of these 83-ton nuclear missiles could destroy a city the size of New York. Creating a submarine to accommodate these missiles and a crew of 150 meant designing a revolutionary hull structure. The Typhoon is the only submarine ever built with not 1, but 2 inner hulls. They run side by side within the 170-meter external hull, improving the Typhoon's survivability. Even if one hull is breached, the crew could evacuate to the other hull for safety. The Typhoon is essentially a floating nuclear power station, generating enough energy to power a small city. Its giant propellers are driven by some of the biggest nuclear reactors ever put on a submarine. Captain Piroshkov's heading for those reactor chambers. He must inspect them one last time before dismantling begins. His path takes him by the sub's various amenities, including the gym.
A sailor on a submarine doesn't have very many opportunities to move around. So on a Typhoon, they had a gym. Here, there's a punching bag. If you want to work on your cardio, here, you have a basic treadmill.
Sub-commanders and their crews lived underwater for up to 4 months. It was a town beneath the sea. And the Typhoon had one luxury not found on any other sub.
Because of its unique size, this particular submarine allowed for a swimming pool, where the sailors could go for a swim.
Captain Piroshkov's destination is Compartment 19, the site of the Typhoon's nuclear reactors. To most of the Typhoon's crew, Compartment 19 was, and still is, off-limits. Most nuclear-powered subs have 1 reactor. The Typhoon has 2. A submarine's reactor is essentially a highly radioactive boiler. Metal tubes filled with uranium fuel tablets serve as heating elements. Water circulates around these radioactive fuel rods, cooling them and producing steam. The steam then powers the submarine's propulsion systems. The reactor is sealed to prevent any radiation from leaking out. At dawn, Captain Piroshkov's team of engineers will begin the dangerous task of removing the nuclear material from the twin reactors. They have wrapped the entire area in plastic. It looks flimsy, but in the worst-case scenario of a radiation leak, it will contain the radioactive particles and protect the crew. This area will be totally off-limits once they breach the reactor's lid and expose the fuel rods. With just hours to go, everyone is on high alert. Captain Piroshkov is about to give the order to breach the Typhoon's reactors. The sub's nuclear fuel rods must be removed from its reactor cores. They'll be encased in these radiation-proof containers and lifted out by this giant 72-ton crane. But the weather may be the wild card in Captain Piroshkov's plans. The shipyard sits 2,800 kilometers from the North Pole. Fierce winter storms with strong winds can strike without warning. A rogue gust of wind hitting the crane while it's unloading could cause a deadly radiation leak. So the crane has an automatic shut-off sensor. If the wind is too strong, the 72-ton machine will instantly shut down. A heavy winter storm threatens the city. But Captain Piroshkov decides to go ahead despite the weather. He gives the order to begin the destruction of the largest submarine ever built. Stage 1 of the Typhoon submarine dismantling. The team begins the removal of fuel from the sub's 2 reactors. Now Viktor Yarmoshenko takes over. He's the engineer in charge of the reactor defueling operation.
We do this to protect the environment. We wouldn't want a radioactive waste collecting on the sea bottom. Also, we're aware that spent nuclear fuel can be used in nuclear terrorism to make a dirty bomb, so we have to carefully remove it.
Viktor's challenge is something the Typhoon's designers never envisioned. He must break into its reactors and remove the radioactive uranium fuel rods without exposing his team or the environment to the deadly radiation.
The defueling process is potentially very dangerous, so we have to maintain very strict rules of radiation safety here and constantly monitor the reactor.
He clears the submarine of all personnel. No one is allowed inside the reactor compartment once the defueling begins. It's simply too dangerous. They load the first uranium rod into a special transport container made of radiation-proof lead. A crane then lifts this lead bottle off the sub and swings each rod into the storage hangar. Everyone is on edge. There's enough uranium in this bottle to kill everyone in the room and contaminate the entire city. The workers guide the fuel rod with extreme care into another radiation-proof drum. Once the rod is safely in, it's sealed. The crane performs this delicate and dangerous operation many times in the next several days. There can't be any lapses of attention, despite the freezing cold or the pent-up tension. The smallest mistake could cause a fatal accident. When the last uranium rod is sealed inside the storage container, stage 2 begins, removing the radioactive liquid coolant from the dead reactors. When the sub was on active duty, the coolant flowed around the hot nuclear fuel rods inside the reactor to cool them and produce steam for the propellers. It's highly radioactive and deadly. The coolant is pumped from the Typhoon's reactor to this storage facility on the docks. Here, the irradiated nuclear coolant is stored in steel containers encased in thick layers of concrete. workers constantly monitor the radiation levels. And this entire facility will be evacuated and sealed. But this nuclear waste isn't just going to sit here. With a turn of a valve, it begins flowing through underground pipes to the processing lab, where the radioactive solids are filtered out. Engineer Anton Chainikov is in charge.
Liquid nuclear waste are the liquids that contain radioactive isotopes. They emit radioactive rays dangerous for the human body. Besides that, this waste contains a variety of toxic additives. So to protect the people who live around here and to protect the environment, there's a certain special way of handling this type of waste.
The radioactive waste passes through a special chamber to trap its deadliest material, cesium. A speck of cesium the size of a pinhead can kill a human within minutes. So they'll dispose of it separately.
The way this works is, the liquid nuclear waste goes through a layer of a special absorbent, which isolates the cesium isotope. The absorbent is held in a special filter, which is here inside a protective container made of thick steel.
The cesium's caught, but the liquid coolant is still far from clean. A second set of filters catch the remaining heavy radioactive particles. It all happens inside these thick steel containers to protect Anton's team. A powerful dryer then turns the solids separated from the liquid coolant into a highly radioactive concentrate, the consistency of salt.
So it means, as a result of the processing, the volume of nuclear waste is reduced by 100 to 1,000 times.
Anton takes samples of the water separated from the radioactive concentrate and sends them to an off-site lab for purity testing. When he receives final confirmation that the water is completely free of radiation and toxins, Anton will order it flushed into the sea. Stage 1 of the Typhoon's dismantling took days. Stage 2, processing liters of nuclear coolant, takes several months. And just like the earlier removal of the fuel rods, constant attention can be the difference between life and death for Anton's crew. Workers continually monitor radiation levels with Geiger counters.
We have documents that set a norm for radiation levels for personnel which can't be exceeded. If the radiation levels go above the norm, it will trigger an alarm and will take measures to lower the radiation levels.
A spill of the liquid nuclear waste would quickly spread radiation beyond this lab, potentially into the soil. It would be nearly impossible to clean up and could contaminate the local area for generations. In addition to the specially trained personnel, an automated system monitors the radiation levels. Stage 2 proceeds. Anton's satisfied. The radiation levels are safe and steady, but that could change in seconds.
If the radiation levels are elevated, the sensors go off and the alarms are triggered, and all personnel are notified.
At the end of every day, each member of Anton's team undergoes a full body scan for radioactive particles. Anton gets the white light. He's in the clear. Several months later, winter has turned to spring. The crew has safely removed all the radioactive coolant from the sub's reactors and stored its uranium fuel rods. Now stage 3 can begin. It may be the toughest challenge of them all. They must maneuver the immense sub into a dry dock barely big enough to hold it, cut it apart and recycle it. And the man in charge of this entire dismantling operation, Captain Vladimir Piroshkov, isn't even sure if this Typhoon will float.
The sub's position in the water has changed. We must make sure it doesn't tip forward or sideways.
The May sun has melted the ice around the Russian nuclear submarine. The crew readies the sub for the last journey it will ever make. It's heading 8 kilometers across the channel to the shipyard's massive dry dock, where it will be cut into scrap metal and recycled. But it's a difficult task to move a 23,500-ton ship that no longer has an engine. Akula, the Russian shark, is now more of a beached whale. But first, the crew must lighten the huge sub, or the tugboats won't be able to maneuver it into the dry dock. And even if the tugs could maneuver it, right now the immense sub is too heavy for the dry dock floor. Captain Piroshkov tours the ship constantly as his crew cut away its missile silos and stabilizing ballast.
This ship is really big and heavy, so we're doing this to lighten the amount of pressure on a dockside platform.
Piece by massive piece, a giant crane drags off what were once integral parts of a deadly war machine, including these missile tubes, the launching point for a nuclear weapon that could destroy a distant city. Now it's just scrap metal, destined for recycling. It takes the crew 3 weeks to strip away the heaviest sections of the Typhoon. The captain's bridge, huge chunks of the outer hull, and parts of the sub's steering and stabilization systems.
So, you see here, the vertical steering fin has been removed. It is really not necessary for maneuvering the sub into the dock, so we cut it off.
They must also remove the sub's unique protective layer.
This is hydroacoustic coating. It covers the submarine hull in its entirety.
The rubber absorbed acoustic signals from the inside of the sub, making it virtually undetectable to the enemy. Typhoon's primary defense against surveillance and attack subs.
In order to dismantle the outer hull, we need to take all this rubber coating off, and the metal is then recycled. The rubber is also recycled. It can be melted down and used to add in asphalt or car tires.
The captain must make sure the Typhoon is ready to be brought into the dry dock. Inside, they will beach her on a flat platform. Anything on the outside of the hull that might cause it to topple over must be cut away while the sub is still afloat. Meanwhile, on the other side of the harbour, the dry dock is ready for the sub's arrival. Engineers and construction workers have built a giant framework of steel and concrete to hold and support the Typhoon. These supports will take the entire weight of the massive submarine when the water's drained from the dry dock. But the sub must be parked exactly above these supports. If she's not, she could topple over when the water drains and crash to the bottom of the concrete pool. Dockmaster Yuri Kavardin must line up the 170-meter vessel with absolute accuracy.
These are the stocks. This is where the ship will be placed. We have to park the ship on these stocks with the accuracy of 50 millimeters. That is the margin of error we have.
The stocks are ready. The tugboats are standing by. Captain Piroshkov's crew aboard the Typhoon reel in its anchoring cables. It's about to begin its final journey. It's a task of remarkable precision. The dry dock was never designed with a Typhoon-class submarine in mind. Its gate is only 25 meters wide. The sub's hull measures over 24 meters across, affording it less than half a meter of clearance on either side. That's a tight fit. And although the Typhoon's nuclear fuel and coolant have been removed, its reactor chambers are still highly radioactive. Worst case scenario, a collision with the dry dock gate could cause a radioactive leak. That's if it gets to the dry dock gate at all. The team has lightened the sub so that the tugboats can now tow it. But stripping it down has made it unseaworthy. There is no manual for dismantling a Typhoon.
As the sub is lightened, it raises in the water. The sub's position in the water has changed. Our goal now to keep it afloat without any leaning forward or sideways.
If the hull leans to one side, it will make the sub impossible to maneuver. The tugboats move into position and attach their massive ropes. Captain Piroshkov gives the order to launch. He'll direct the sub as far as the dry dock gate. The tugboats control the Typhoon's every move. This giant is now completely helpless. The Typhoon moves at a snail's pace, a far cry from its submerged top speed of 50 kilometers an hour. Centimeter by centimeter, meter by meter, tugboats and sub approach the dry dock gate. Then one of the tugs pushes too hard. It's a tiny miscalculation, but it's magnified by the sheer size of the monster sub. The sub swings right. The momentum from its 23,500 tons can't be stopped. It slams sideways into the guiding posts near the dry dock gate. The tugboats scramble. If the hull's been breached, the sub could sink where she sits and block the access to the shipyard. The crew rush to assess the damage. They inspect the sub's hull for the slightest tear. It's intact. The tugs continue nudging the Typhoon to the dry dock's entrance. From this point on, Dockmaster Yuri Kavardin is in charge. The sub is almost as wide as the gates themselves. It's already had one collision. Another could breach the hull and cause a leak in the still radioactive reactor compartments. Everything's down to Kavardin's directing skills. It's like parking a tank in a garage built for a car. Kavardin's skill is holding, so far. There are just centimeters between an immovable wall of solid concrete and the monster submarine. The Typhoon slowly enters the dry dock where its date with destruction will take place. Dockmaster Yuri Kavardin must guide the Typhoon through the gates with barely an arm's length of space on either side. The tugboats can't fit through. Now it's down to human power. On Yuri's orders, the crew man ropes and pulleys to pull the immense submarine through the gates. And they're racing the low tide. If the tide turns before they get the Typhoon inside, the current will drag it back out into the main channel. The entire day's operation will have been wasted. Against the clock, muscle power moves the mammoth sub its final meters. Just as the tide begins to turn, the gates swing shut. But Yuri's most difficult maneuver is yet to come. He must position the Typhoon in place, by hand, precisely above the adjacent supports. Right now, the supports are out of the water. The sub must be floated above them. To do that, Yuri needs more water to maneuver in. Huge pumps turn on. Water surges into the massive pool. Over the next 4 hours, the water slowly rises. Finally, it's high enough to begin moving the sub. Ropes fan out. The crew is ready. Yuri takes precise measurements of the sub's position. He must line up a ship the length of nearly 2 football pitches over the supports with the tiniest margin of error. Just 50 millimeters, about the length of 2 hairpins. If it's not aligned exactly, when the water drains, the Typhoon could overbalance and crash to the dry dock's concrete floor, with its 2 empty but still radioactive reactor chambers. Yuri checks and rechecks the measurements. They're not adding up. He sends a diver down for a visual check. The diver moves along the hull, reporting back.
Tell me the distance between the stocks and the sub. Good. Good.
After 20 minutes, he resurfaces. As far as he can tell, the sub is in position. But no one will know for certain until it comes down. This is it. The tugboats leave the dock. Massive pumps turn on, slowly sucking the water from the dry dock. The Typhoon, the biggest submarine ever built, is revealed in its entirety. Not since it was created as one of the Soviet Union's most devastating weapons of war almost 30 years ago has the Typhoon been seen like this. Longer than 15 double-decker buses, nearly 4 stories high, and as heavy as 75 jumbo jets. These are the last moments of the world's largest nuclear submarine. And Yuri Kavardin has brought it in.
Трудно, но успешно, удачно.
It was difficult, but everything is successful. The ship is sitting within the parameters, so all is well. How I feel right now? Just tired, but also happy that it went well.
His job is done. Now it's time to turn this once mighty war machine into scrap metal. The Typhoon began as a triumph of Soviet nuclear engineering and shipbuilding. Now it's simply an immense lump of steel. But not just any steel. The Typhoon was made from only the best and the strongest steel in the Soviet Union. Russia needs this super steel for future projects, and the Typhoon can provide thousands of tons. There's only one way to cut a monster like this into pieces small enough to melt down: by hand. Every day, workers armed with blowtorches cut away another section of the sub and winch them away to giant metal cutting machines. Day after day, chunk after chunk, month after month. Eventually, the Typhoon goes from submarine to giant metal carcass. Now all that steel must be recycled. They haul it to another part of the shipyard, run by engineer Andrei Meshkov. He's in charge of the special machines that will process the thousands of tons of Cold War steel.
You can make whatever you want with it. It's used to make pipes, support beams, sheet metal.
Stage 1 of the recycling process, slicing up the giant sub by hand. Andrei's team sets to work with blowtorches. It's all about cutting the steel into smaller and smaller pieces. But nearly a year has passed since the entire operation first began. It's midwinter again, making work tough for Andrei's crew.
When a man is standing there with a blowtorch, it's hard labor. They hold the blowtorch in their hand all day long, outdoors. Sometimes it's windy, freezing, snowing. These people work really, really hard.
The cut steel chunks go into a giant guillotine, which chops them even smaller. Once, the Typhoon's protective outer hull withstood incredible pressure as it cruised the ocean's depths. But now the guillotine crushes that same hull like a piece of cardboard. Not much goes to waste when a submarine gets recycled. One of the sub's most valuable components is its hundreds of tons of copper wire. But the copper must be separated from its rubber insulation, or it's worthless.
Of course, it's easier to just trash the cable, but we want to recycle them and get the valuable metal that we can reuse. So we built this machinery, so we don't have this mixed waste of metal and rubber together. We're decreasing the amount of waste produced in the process of decommissioning.
Specially designed machinery separates the copper from its insulation. And churns out fine chips of pure copper ready to be resmelted. The Typhoon is now almost completely dismantled. There's virtually nothing left of the gigantic sub that once weighed over 23,500 tons. What does remain is too dangerous to recycle. The small core that once housed the sub's nuclear heart, its twin nuclear reactors. Its uranium fuel rods and coolant have been removed, but its 2 reactor compartments are still radioactive. They remain attached to 4 empty compartments to shield the radiation and keep the sub afloat. This metal can't be used again. The whole block must be towed to a Russian nuclear waste site on a remote island off the Kola Peninsula. Dockmaster Yuri Kavardin is in charge again. He'll direct the reactor chamber off its supports and into a deep section of the dry dock, where it can be towed out to the open harbor. But first, they must flood the dry dock. 3 huge pumps force in millions of liters of water. The operation lasts 3 hours. 3 million liters. 7 million. 11 million. The dry dock slowly fills. Finally, at around 15 million liters of water, they stop the pumps. The reactor compartment is afloat. Now Yuri must maneuver it into the deeper part of the pool and outside of the dry dock's gates. The team's last risky mission is getting rid of the sub's deadliest component. Dockmaster Yuri Kavardin must position the Typhoon's reactor block in perfect alignment with the dry dock's gates.
Every operation at the dock is an exciting event. It's always a unique event, especially when you realize that this is the finale for the work of hundreds of people. Right now, the work that you see here at the dock is a little bit sad. It's sad because when we received this ship here, it was a Navy ship in all its glory. But it's leaving us like this, in this sorry state.
Little by little, Yuri guides the reactor block into the deep water. Right now, the water level inside the dock is higher than the level outside the gates. Once the reactor block is in position, they will drain the dock until it's level with the sea outside. But if the reactor block is out of alignment by as little as 1 meter, it could hit the shallow concrete floor, crack, and spring a radioactive leak. Yuri checks the measurements again and again.
Right now, the water is going down, and I'm checking its position from 3 viewpoints.
Finally, he's satisfied and gives the go-ahead to lower the water levels. The gates open one last time for the Typhoon.
We are ready for anything. This is like a living being. We don't know how it's going to behave. We'll have to adapt and try to tame it like a caged tiger. This is something we've done before, but I can't say it's an ordinary operation.
The workers attach 7 pulleys with heavy-duty ropes. They will control the movement of the reactor block manually, tightening or loosening each rope as Yuri orders. The tugs are in position to push the block out of the dry dock. On Yuri's commands, the workers slowly pull the floating lump of steel through the gates. There's only a meter on each side to maneuver. It can't be allowed to collide with the gates. A collision could breach the radioactive reactor chamber. All eyes are on Yuri. His orders need to be obeyed instantly. The reactor block squeezes through with only centimeters to spare. The last nerve-wracking operation on the Typhoon's year-long dismantling is over. The reactor block, the final remains of the once massive submarine, sets off on a last journey to the nuclear waste site 800 kilometers away. For 2 decades, the Typhoon prowled the oceans of the world, the Soviet Navy's supreme underwater trump card in the Cold War. Now this submarine is no more. Its reactors emptied of nuclear fuel, its nuclear waste processed, its steel recycled for peaceful purposes. Captain Piroshkov and his crew chiefs gather a final time to reminisce and remember. They pour the vodka and raise a toast, a farewell to glory, to the passing of the Typhoon, the greatest submarine ever built.